Let me start with a strange observation. Some of the smartest people on Earth, people who can explain the universe, cure diseases, or invent new materials, keep building companies that nobody wants to buy from. Not bad companies, not stupid ideas, often brilliant ideas, and yet no customers. So the question is not, why do bad ideas fail? The real question is, why do brilliant scientists keep building companies nobody wants? This pattern shows up again and again. Highly intelligent people, doing serious work, creating technically impressive companies, and the market simply doesn't respond. No urgency, no buying behavior, no pull. It's tempting to assume the market is irrational or too slow, or doesn't understand the value yet. But when the same pattern repeats across fields and decades, it's usually not a coincidence. It's a structural mismatch. Imagine you spend 10 years building the world's most perfect hammer. Perfect balance, perfect materials, scientifically elegant. Now you walk out into the world and discover that most people are dealing with screws, not nails. The hammer isn't wrong. It works beautifully. It's just aimed at the wrong problem. This simple parable explains far more startup failure than bad engineering ever does. Here's the pattern. The solution works. It's scientifically sound, technically elegant, and demonstrably superior. The market shrugs. There's no urgency, no budget, no willingness to switch from existing alternatives. So the scientist persists, believing that education, time, or better explanation will eventually reveal the value. This loop repeats across industries, technologies, and generations. To understand why, we have to look at how scientists are trained to think. Scientific training optimizes for three things. First, defend originality. Your work must be novel and distinct. Second, maximize internal coherence. Your model must explain reality cleanly, without contradictions. Third, win peer recognition. If experts respect it, validate it, and cite it, you've succeeded. This training is extraordinarily powerful, but it also quietly optimizes you for a very different game than markets are playing. This training produces breakthroughs, paradigm shifts, and technologies that reshape civilization. But it also creates something subtle and dangerous, a cognitive pattern that becomes nearly invisible to those who possess it. The better you are at science, the harder it is to see. I call this pattern epistemic overfitting. It's not a flaw. It's a side effect of excellence, one that becomes costly when science meets markets. In machine learning, overfitting means your model explains the training data so perfectly that it fails in the real world. Scientists experience a similar version. You build a model or technology that explains reality beautifully. Then a hidden assumption creeps in. Because this is correct, the world should reward it. But the market's response is usually indifference, because truth alone is not what markets optimize for. Markets don't reward correctness. They reward pain relief. Does this eliminate an active, expensive problem? Risk reduction? Does it make something safer or more predictable? Convenience? Does it reduce friction or save time? And timing? Does it arrive when buyers are ready and able to pay? Truth is necessary but insufficient. Markets operate on urgency, not elegance. For a scientist, the solution is not just a tool. It's identity. Years of effort, reputation built on expertise, self-worth tied to being the person who solved this specific problem. So when the market says no, it doesn't feel like feedback. It feels personal. And that emotional coupling makes adaptation extremely difficult, even when the data is clear. Scientists are trained to defend correctness, educate the market, and wait for recognition to arrive. Entrepreneurs do the opposite. They abandon solutions that don't sell. They listen obsessively to what customers actually need. They pivot quickly. They treat rejection as valuable data. The hardest part is that abandoning the solution often feels like abandoning yourself. That's why the shift is brutal. There's a massive interpretation gap. What scientists often hear is, your life's work is worthless. You wasted years. But what the market actually said is much simpler. I don't have budget for this right now. This doesn't solve my urgent problem. Or just, not yet. When feedback becomes personal, Iteration becomes impossible, and progress stops. Here's the uncomfortable truth every scientist founder must internalize. Markets don't care how hard something was to invent. They don't care how elegant the solution is. They don't care how many papers support it. They care about one thing. Does this make an existing pain disappear right now in a way people are willing to pay for? If not, nothing else matters. If the answer is no, the market moves on. Not out of cruelty, not out of stupidity, not out of conspiracy, out of indifference. Because the market has infinite problems demanding attention and finite resources to allocate. Indifference is not a judgment, it's a signal. Ignoring that signal is where years quietly disappear. When a scientific startup fails, it's usually not because the science was bad. More often, the problem wasn't urgent, the buyer wasn't clear, the timing was wrong, or the solution arrived before the pain was widely felt. These are not moral failures, they're coordination failures between technology, incentives, institutions, and time. And coordination obeys very different rules than discovery. In other words, the hammer was excellent. Engineering flawless, materials optimal, design elegant. There just weren't enough nails, or the nails were already hammered, or people preferred screwdrivers, or the nails weren't painful enough to justify action. None of this makes the hammer bad. It just means excellence alone doesn't create demand. This doesn't mean scientists shouldn't build companies. It means something much more important. Commercialization is not a reward for truth. It's a coordination problem. And coordination follows different rules than discovery. Once you understand that, failure stops feeling mysterious and starts looking predictable. And predictable failures are the ones you can actually design around. Scientific discovery and market coordination optimize for different success metrics. Science rewards peer validation and elegance of solution. Markets reward customer urgency and adoption. The skills that make you exceptional at research can actively hinder commercialization. That isn't failure, it's specialization. Problems arise only when we assume mastery in one domain automatically transfers to the other. There is a path forward. First, recognize the pattern. Your training optimized you for one game. Second, separate identity from solution. You are not your technology. Third, learn market literacy with the same rigor you applied to research. And finally, build for pain, not elegance. The best solution isn't the most beautiful one, it's the one customers actually buy. This raises a bigger question. If research is so valuable, why do most university spin-offs fail? In the next video, we'll zoom out and look at systems, incentives, and institutions. Because universities are optimized for discovery, not coordination. And once you see that architectural mismatch, an enormous amount of failure suddenly makes sense. Understanding this early can save years. Many years are spent perfecting solutions before confronting market reality. Most university spin-offs never reach product-market fit. And the single most important mental shift is this: markets reward urgency, not truth. If you're building or thinking about building something based on research, this distinction matters more than your technology's elegance. See you next time.